In this video, I want to discuss the difference between a strong acid and a weak acid. So first, let's discuss what is a strong acid. There's going to be a list of strong acids that you're going to need to memorize that I'll write on the right-hand side here. But first, let's take a look at a simple example. Hydrochloric acid can react to form H plus aqueous plus chloride aqueous in the presence of water. And so this ionizes 100% here. When hydrogen chloride gas enters water, you're going to form a hydrogen ion and chloride ions. Now there are 2 points. First, we say that the reaction ionizes 100%. That means it ionizes completely. And the second point here is that it dissociates 100%. That's just a different vocabulary word to say the same thing. Now, we can graph out what kind of is happening in this chemical reaction. So we have a graph on the left of 0 to 100%. And we have an initial situation and a final situation. So initially we have hydrogen chloride gas that's 100% present, okay? And that's what we're starting off with, 100% hydrogen chloride. Now, when it hits water and it dissolves and begins to react, what do we get? Well, first we also have no H plus and no chloride in the initial condition, so I'll sketch in some very small error bars here. So when HCl reacts with water, the HCl bond is cleaved, it breaks, it dissociates, we say. In the final conditions, we're going to want to draw in error bars here for the HCl. So the HCl has a concentration of 0, and the concentration of H plus is 100%, and the concentration of chloride is 100%. Okay? Okay. This process is 100%. Now on the right here, I want to list out the strong acids: hydrogen chloride, hydrogen bromide, hydrogen iodide, nitric acid, sulfuric acid, and something called perchloric acid. Now, some textbooks include another structure, but most textbooks don't, so I'm not going to include that here. So these are the 6 strong acids you really need to memorize. All right? So that's the basics of how a strong acid works, and it reacts to form 100% ions in solution. Now next we want to talk about, so how do we calculate the H plus or the pH of a strong acid? The first thing you want to remember is that the concentration of HCl is equal to the concentration of H plus, and this is only valid for strong acids, okay? The second thing is that you use the pH formula. pH is equal to minus log of H plus. And so this is how you would use the numbers to find out what the pH is. So it's a very simple calculation, relatively speaking. Next, I want to discuss what is a weak acid. Now, if you were asked to calculate the pH of a weak acid, there would be many, many steps involved, okay? And the reason why is because of this equilibrium situation. Now, there are many weak acids. there could be a table of them, and generally a problem is going to include the Ka, and that's how you know if you have a weak acid. Now I'm going to use formic acid as an example here, and this is a weak acid. And we want to show the aqueous form of this reacting in water, and we use these equilibrium acids, okay? So this molecule dissociates to form H plus and formate ion. So these are both aqueous, and we want to write the phases of the ions present, okay? So H plus, remember again, is the business end of an acid, and then we form the conjugate base as well. So let's label what's going on here. So we have two ions that are being produced here, and we have a molecule in the starting point. So let's sketch out kind of what's happening here as a chemical reaction. So initially we have 100% formic acid, and we don't have any of the ions present, okay, not initially. And then we add water to this so that it begins to dissolve and react and ionize. Now, because it's at equilibrium, we know this because of this weird arrow notation, you're not going to form 100% of the ions. So after the reaction, as a fake example, you might form 97% of the HCO2 minus, and maybe 5% of the conjugate base, and 5% of the hydrogen ion. Okay? So this is a vastly different situation. Okay? And we say that there's a slight dissociation. At equilibrium, you have mostly formic acid present and very small amounts of H plus, and that's why it's a weak acid. Okay? Now, we can calculate various things, such as the percent ionization, but the thing to remember is that the percent ionization is low for weak acids. Okay? And that's the main difference between a strong acid and a weak acid.